Okay, thanks everyone. We're going to kick off. So firstly, just welcome everyone. Thanks for coming along tonight and joining us in this great venue. Both for those of you who are in the venue here today, and I know we've got a bunch of people joining us online. So welcome, good afternoon, good evening. Before we kick off the presentations, I've just got a couple of messages which I'm just going to run through. So firstly, I'd just like to begin by acknowledging the traditional owners of, firstly, the land that we're meeting on today. So that's the Whadjuk people of the Noongar Nation. And I'd also like to recognise the Gamai Walyabari Yidi people of the Cairns region, whose traditional lands the project we'll be talking about tonight was carried out on. I acknowledge their connections to land, water and community, and we pay respects to their elders past, present and emerging. I've just got a couple of PIANC announcements to run through. So firstly, many of you may have attended the PIANC APAC conference in Fremantle. We're at the 1 year anniversary from the inaugural PIANC APAC conference. You may have seen recently that PIANC Australia New Zealand has announced that the next APAC conference will be in Melbourne in September next year. So mark your diaries, block out some time. There'll be more details coming out about that and call for papers and all that kind of stuff. So keep an eye out for that. There'll be more details coming. Secondly, we've just launched, PIANC Australia New Zealand's just launched a new membership tier. So we're now offering free student memberships. So if you know any students who are studying relevant courses or who are interested in the space, let them know, get them signed up. It's a great way for the sort of next generation of professionals in our industry to get involved with what PIANC's doing and help them to become the next leaders in our field. We do have two great sponsors for the event tonight, and I just wanted to thank them briefly. So firstly, Hall Contracting. Hall's been in operation for more than 75 years, and they're Australia's largest privately owned dredging, civil, construction and marine civil contractor. They've got offices here in Australia, in the Asia Pacific region more broadly, including the Pacific Islands. And they've got an advanced fleet of backhoe and cutter suction dredges, which we'll be seeing some of their work tonight. That includes the largest Australian-owned backhoe dredge, the Woomera. In 2019, Hall used the Woomera to assist in the widening and deepening of the Trinity Inlet shipping channel as part of the Cairns Shipping Development Project, which we'll be hearing about tonight. Hall's experienced in delivering capital and maintenance dredging projects, as well as land reclamation works and marine civil infrastructure for ports and harbours. Our other sponsor for tonight is BMT. BMT are a leading international multidisciplinary engineering, science and technology firm. They offer a range of services in the environment, energy, shipping, ports and defence sectors. We've got a few people from BMT here on tonight. They've been involved in several major port design and development projects in WA and beyond. They have in-house commercial software for ship simulation and hydrodynamic modelling, which allows them to address clients' challenging numerical problems. In addition, they have expert material handling, naval architecture and port development team members, which enable BMT to service a wide range of clients in the port and resources sectors. So I just want to ask everyone to join me in thanking our sponsors for tonight. Okay, we're going to get into the presentations for tonight. We've got two great presentations from Tim Green and Charlie Bicknell on the Cairns Shipping Development Project. Just to explain the format to tonight, we've got the two presentations, firstly from Tim and then from Charlie, and then we'll just have a panel Q&A. So if you have any questions, please just hold them to the end and we can address questions to both Tim and Charlie. For those of you who are joining us online, if you write when we get to the Q&A section, put your questions in the chat and we'll be able to put them to Tim and Charlie as well. I think just before we get on to Tim, our first speaker, we do have a short video to play, which is from the project. So I'll just see if I can get that going. For those of you who are joining us online, we do have some restrictions with the audio video setup here. So I have dropped a link in the chat, so you should be able to play it yourself on your own computer. If not, it will be playing on your screens. You just won't be able to hear the audio. There are subtitles, so you should be able to follow along, but hopefully we can make that work some way. You can watch it some way through those couple of methods. So I'll just tee that up if you just bear with me. Nice little ad for the timber cabinet people there. We'll just I'll just bring up, if you bear with me, our next slides. Okay, I think we're all good. Okay, so I'd just like to introduce our first speaker for tonight, Tim Green. Tim has more than 20 years experience in the delivery of maintenance and capital dredging and marine works across Australia. During his time, he's carried out the full scope of projects from site investigations, tender prep and evaluation through to construction management. On the project which we're going to be hearing about tonight, Tim joined following the decision to rescope the project which was after the introduction of legislation in the Queensland government which banned the disposal of dredge material at sea. Tim was involved in the disposal site selection process, engineering design support for the approvals, the tender documentation, and then all the way through to superintendent for the dredging and disposal works. And please join me in welcoming Tim.
Thanks very much, Joel, and hello to everyone here and hello to everyone online. Hope you enjoy this talk. So yeah, as mentioned, I'll probably be talking more about the lead up to the works, the approvals and the engineering and some of the challenges that we went through in that. And then Charlie's going to follow up with the contractor experience. Firstly, as Joel mentioned, this project's been around quite a long time. It was initiated back in 2011, so I think it's appropriate to really acknowledge that there has been a hell of a lot of consultants involved in this project over the years. We are just one small part of it all. BMT has been involved from the beginning in various roles, but yeah, there have been a lot of people that have contributed to this project getting approved and then getting completed. So, you know, thanks and congratulations to those people as well. Just so you can understand the context of where Cairns Port sits relative to everything. I wonder if I can. Is this going to work, Joel? Two options. So the port sits very close and in proximity to the Great Barrier Reef Marine Park. So the Marine Park boundary is actually out here on the yellow line, but it sits within the World Heritage Area, which extends right up to, I think it's to LAT or HAT along the shoreline. So the port actually sits within the World Heritage Area and quite close and adjacent to the Marine Park itself. There's also a number of other zones around the port for conservation zones, fish protection areas. So it's all quite in close proximity to a lot of sensitive environmental areas that need to be looked after. Worth noting, there is an approved existing dredge material placement area that's located within the Marine Park boundary, which is the area that the port used for maintenance dredging works, for which they do around about 400,000 cubic metres per year, which is interesting in the context of this job, which was about 800,000 cubic metres of capital work, so 2 times a maintenance job. As you would have heard in the video, the project involved the dredging as it was delivered around 800,000 cubic metres of material to deepen and widen the channel to allow better access for the cruise ships. This was all done pre-COVID, of course, so little did they know that the cruise ship industry would take such a hit for a while. The dredge material was 90% fine sands and silts, and the rest of the material was even finer than that. So it was not very good material, limited beneficial reuse opportunities for the material. After the project was rescoped, they had to find a new disposal site, and they went through a full multi-criteria analysis. You can see the image on the right there is some of the sites identified and included in that multi-criteria analysis in order to come up with the final selected site, which was Lake Norell at the Northern Sands site. It's a registered inert waste disposal facility and also an operating sand mine. So there was a contractor out there with a dredge in the pond extracting sand for commercial use. It was, yeah, as noted also before, it's about 5 kilometres inland and a further 3 kilometres offshore to sufficient water depth for the dredge to hook up to the pipeline. So it was an 8-kilometre long pumping line. Flanagan Consulting Group have since been acquired by GHD, led the preparation of the revised EIS with support from BMT and a range of other consultants in putting that together. The revised channel design, as you can see there, it was a channel width that varied from 90 to 140 metres and depths that ranged from -8.3 down to -10.3 metres LAT. There were deeper areas at selections along the channel to accommodate higher siltation rates, so they had a greater insurance depth in there. And this was the updated channel that they managed to get the volumes down to that 800,000. We'll talk about the initial proposal a little later on. Just so you can see where everything is. I think Charlie may have a few more slides on this, but you can see the Port Authority is located right adjacent to the Cairns CBD. They've got a number of wharves in along here. And the Tingira Street that you saw in the video where they took the stiff clays on is just located just to the south of the port, still in an industrial area, but on port land. the channel extends out through Trinity Bay. Probably just off the top up here is Green Island, or if anyone's been to Cairns to have a look, it's one of the sort of more popular tourist visiting destinations, and the sort of outer reef proper is just out beyond that. The pipeline route extended, across the water, over a bunch of cane land, across a tidal creek, and then finally reached Barron Delta after a couple of railway line and a major road crossing as well. The project, it's had a long gestation period. It was first initiated in 2011 when it was recognised that the cruise ship market was growing. I think it had been growing for about 10% year on year, and recognition that the vessels were also getting larger and requiring greater drafts to access the port. Quite a lot of the vessels had to anchor offshore up at Yorkeys Knob, and the crew, the passengers were then shuffled to shore to then do their shore visits and go and spend their tourist money, which was a less than ideal situation for the experience of the tourists and the opportunity to explore the region. So they wanted to be able to bring more of these cruise ships into the port adjacent to the city, so that experience could be much better. So in 2011, they started the preparation of project design and environmental studies to go towards preparing an EIS. And at the time, the proposed channel was around 140 metres wide to a depth of, I think, 9.5 metres LAT, but a volume quite substantial of 5 million cubic metres. And they were proposing at the time to use that marine offshore disposal site that I highlighted in the earlier video. So all the studies were based on that proceeding. Then in 2014, while they were still going through their studies and plans, that's when the concerns over the Great Barrier Reef World Heritage Area were raised by UNESCO. And at that time, they made some recommendations that they might place the World Heritage Area on the endangered list in 2015 if the government failed to address the concerns that they'd raised, which certainly triggered a lot of action in government due to the significant value of being a World Heritage Area and of the reef itself to the community in Australia as a whole. A later study, I've got my notes up in front of me, in 2017, I think it was by Deloitte, valued the reef at something in the order of $60 billion to the Australian economy. So it has significant economic value as well, and the maintenance of that is economically as well as environmentally something important. So in 2015, while those concerns are being addressed by government, the port lodged their first EIS for the channel deepening project based on the initial scope. And then in June 2015, the government introduced legislation to ban the disposal of capital dredge material in the marine park at most ports. I think there was 4 ports that were given an approval or were allowed to continue their capital dredging works, but Cairns Port was not one of those. Maintenance dredge material, I think, is still allowed to be disposed in marine sites, but not capital material. And I think, unfortunately for Cairns Port, they didn't export enough black product to get the tick to keep going. So they had to rescope their whole project. So the project was put on hold while they figured out what they were going to do. In 2016, they did some navigation simulation to try and sort of refine the channel and reduce the volume to something that maybe they could handle on shore. And in doing that, they managed to bring the volume down to around about 1 million cubic metres. And they thought that's probably something they might be able to handle. And they commenced a revised EIS, environmental impact statement, based on this rescope channel design, which included a search for a new dredge material disposal site onshore or marine reclamation from shore that still met the requirements of the legislation. This went on for 2 years, or nearly 2 years, and in late 2017, the environmental impact statement was submitted and it was approved by the Queensland government, which essentially gave the port the approval to proceed with going and getting all their secondary and follow-on approvals. It basically gave endorsement that it was believed the project could be managed based on what would be presented and subject to completing some of those additional studies and additional works, which were more about sort of the detailed design. There were a substantial amount of additional approvals that had to be sought after that, and it took a further 14 months for those to be approved, and I think a little bit later on. They did a little bit more channel design reviews and managed to get the volume down to about 800,000 cubic metres after that. So yeah, February, that report came out saying that they could proceed. They issued tender documents in November, received tenders in December, and in January awarded a contract. So probably one of the fastest procurement processes coming out of a government, quasi-government agency that you'll see for a while. So it was quite speedy. They had to get it up and going quickly because there were some weather window, environmental time periods that had to be done. So if they missed that period for starting dredging by April, it would have been pushed off again to 2020. And in hindsight, knowing what has happened with COVID, the project may never have gone ahead. Contract was awarded in January. Site works commenced in April with some civil earthworks onshore around the reclamation or the disposal site and pipelines. Dredging commenced in, I think, the last day of June, early July, and was completed in September. And in November 2019, a majority of the works onshore had been completed, and practical completion was issued to the contractor. And as noted in the promo video, wharf extension and modification works continued through into 2020, which are not really part of this discussion or this talk. Just to give you an idea, the revised draft EIS table of contents, which is available if you search it up at the Queensland Government site, was quite extensive, with quite a number of appendices, and I think there was another 15 to 20 reports issued as supplementary documents following the questions that then get raised during the public submissions period. It covered a whole range of topics and areas with a lot of studies and a lot of different people involved and consultants involved in getting there. Some of the secondary approvals that had to be sought after that first EIS was kicked off included the EPBC approvals from the federals, state government approvals for capital dredging works, the environmental authorities, for example, for dredging and placement onshore, approvals from the marine parks to construct the pump out facility, which was, I think, on the border of the marine park area. Local government works approvals for the different operations, such as operating the Northern Sands, because it was a sand mine, and then they're going to use it for a reclamation area, so that's a change of use and required approvals. They had to get approvals for putting in bunds, like a works permit from local government. Capital dredging from the port itself, because they are the licensing authority for capital works in their facility. Just going through that, they had to get a quarry license to dredge sand out of the channel from the state government because it's extraction of sand. Traditional owner, cultural heritage approvals from 3 different TO groups. Department of Transport, because they're placing a pipeline under a major highway. They had to get separate approvals from Department of Transport to work in that road reserve. And I think there was a few, there was going to be some impacts to protected species, which I'd cover a little bit later, ant plants in particular, one of them. In all, there were 539 conditions issued on the project from 8 agencies across 3 levels of government. And a lot of those conditions didn't all necessarily interlink with each other, and some of them were contradictory with each other. So it made it quite a challenge, one, to keep track that compliance was being achieved on all of those, and also, just trying to manage all of those and cover them all in your management plans was quite tricky. Just going on to the reclamation or the disposal area, just for those without a dredging background. In a perfect world, here's your reclamation area. Your material gets pumped in after it's been put into a slurry, and it comes out the end of a pipe and settles in the water. Your heavy stuff settles out earlier, and then your fine stuff can flow under as a density flow or in the water column along. And the longer it's in there, the more that settles out. And at the end of the day, hopefully you've got nice clean water being skimmed off the top and discharged back to the environment. It can be disturbed by wind that can stir up the water as well and impact on your discharge water quality. Obviously, the fineness of the material impacts how easily it settles and settles out. And so you've got a whole bunch of processes that occur in a nice square rectangular reclamation like this, which unfortunately is not what we had. You can see there, this is the Northern Sands or Lake Narelle site, which was sort of a horseshoe shaped. It was shallow at this end, and there was quite a deep hole at this end. It's a sand mine and waste disposal facility, and some of the challenges in getting it approved and designing it were that the sand mine the capacity had to be large enough to accommodate all the dredge material after it had been bulked up and put in a slurry and pumped out by the dredge. So The bulking factors range, the estimated bulking factors range from anywhere between 2 to 3.5. So if you dredge 1 million cubic metres, you might need 3.5 million cubic metres just to contain the solids in a worst case scenario. So there is this requirement to have this hole as big as possible, as deep as possible, which you can make it deeper and have more capacity by building up the bunds around it. Unfortunately, because it's in the floodplain of the Barron River, which you can see passing by here, which in extreme wet weather events overtops and floods into here, you can't build the bunds up too high because you could have an impact on adjacent properties, because you can cause an upstream increase in flood levels, which you can't do because it's not fair on those people that you can impact on them by changing the downstream flood flow. So we had this sort of push-pull constraint on the site. As we were doing our studies over the 2 or 3 years, the contractor was also continuing to mine sand out of the pit, so it kept changing in volume and capacity depending on the sand miner's whims of what he was going to do. He was also dumping inert waste that was coming in from the community in there as well. So there was, that was sort of some of the real challenges. And the definition or estimating the bulking factor of the material, it's not a precise science, and it required quite a lot of innovative studies. And one of the things that BMT did was actually come up with a new design process for trying to estimate how this material was going to bulk up and how it would settle over time as it was placed in the pond at depth. So as it's sitting in the pond, it also then compacted down, and it was quite important for the port to know how long before this material could go low enough that they could discharge more of the water, particularly because they needed to get it low before the next wet season, so it wouldn't, maybe remobilise if it was flooded. So it was really interesting in that. There was also the issue of groundwater. Adjacent to the site is a whole bunch of sugarcane farms, and also the Barron River right next to it. The Barron River is predominantly brackish in the dry season, but in the wet season, obviously it's got a lot of freshwater flows. So there's water coming in and out of Lake Narelle from the Barron River. And if we built up the water levels too high in the pond in Lake Narelle, there's a chance that we could push the salt water out into the adjacent groundwater and impact then on the sugarcane farmers. So from an engineering and dredging perspective, we want to fill it up as high as possible and let it retain for as long as possible to get clean water to discharge. But from a groundwater situation, we want to keep it as low as possible so that we don't impact on the adjacent farm. So again, another push-pull scenario going on there. As mentioned, we also needed to get the sediment and water levels back down to an acceptable level before the onset of the next wet season, so that if there was a major flood event that overtopped the bunds or came into the pond, it didn't wash everything back out again and cause a mess. Just to add to the sort of complexity, there was also potential acid sulfate soils identified in the dredge material. And this material had to be dredged as soon as possible and placed in the bottom of the deeper area of the pond, and then covered with the rest of the material so that it once stayed below water as deep as possible, so it wouldn't oxidize and form acid water. But then also that had to be balanced with the dredging cycle and the dredging program to firstly get access to this material in amongst everything else that went on. The water quality discharge criteria was set at 50 NTUs for discharging the tailwater back into the Barron River. Unfortunately, this was despite all of the previous modelling being done at 100 NTU, showing no major impact, but the regulator took a decision to make it 50 NTU just to be extra conservative, which equated to, for this material, around about 80 milligrams per litre, which was pretty tight. And caused a bit of an issue, which I've got a slide on coming up later on. There were also maximum volumes that were allowed to be discharged per day into the Barron River. So it wasn't just a quality, it was a quantity of the material going back in. So when it came to actually doing the job, unfortunately in 2018, there was a major flood event in the area. And this is the site in, I think it was March 2018, the year before we turned up. So this is the sort of that deeper area, and then the hook around here is all the contract or the operator's facilities underwater, and the river flooding across here. So the pond got filled up with a bucket load of sediment from the Barron River, and we had this 50 NTU criteria. And actually, the problem was before we even started dredging, before we even started filling the pond, we were already in exceedance of our allowable discharge criteria. So we had a bit of a challenge there to make sure that the contractor could get on with work, because actually this is not a contractor's issue. This was a client issue to resolve before they started. So I think post floods, it was around 200 NTU. When we got there, it was about 80 NTU. So what we did is we collected a bunch of samples and then we sent them off to a lab in Brisbane to do some flocculation tests using commercial flocculants, but also doing one using salt water as a flocculant. And what we found was that even at a 5% dilution with salt water, you could get the turbidity down to less than 10 NTUs within a 24-hour period in a small jar. So we looked at different, here's just some of the outputs from that work, which was quite interesting. That even as low as 5% mixing or 5% concentration of salt water in the mix, within 24 hours, you can get a significant drop from the control for your turbidity value. So we made the decision to use the dredge to pump salt water into the pond. I think it was for about a day, 2 days, and then see if that could help flocculate out the clays and the fine material that was in the freshwater-based northern sand site. And luckily, it actually did have a remarkable and very rapid response. And I think within 2 days, all the levels were back down to an acceptable level, which meant the contractor could get on with their works. So that was quite an interesting sort of challenge that we had to overcome early on. And the use of seawater probably worked a lot better than we thought it might. Just looking into some of the execution challenges, and I think Charlie might cover some of these. There was a dredging environmental window, April to September, which was partially based on being out of the site before the wet season came, but also to do with I think it was some of the fauna offshore, the seagrass beds and the corals, to minimise impact on those. They identified potential unexploded ordnance in the swing basin, and that came fairly late in the piece when that magnetometer survey turned up. So some pretty sort of quick work had to be done to work out how to clear that and check that to make sure there was no issues. As mentioned, there's a long pumping distance, so really it required a dredge with a large pumping capacity, but the dredge also had to have a shallow draft because the site's quite, the channel's not that deep and there's big tides, and also the closer you get to shore, the shorter the pumping distance. There were stiff clays in the design profile that you might have been able to remove the trailer hopper, but then you would have impacted your productivity and potentially blown out your window. So the solution then was to bring in a backhoe and barges and use that material on shore. We also didn't want to fill up the capacity in the site, in the pond, with material that we didn't have to, because we were concerned we were going to be constrained. There were noise conditions issued for operating in and around the port near the city due to the presence of the hotels and the residential and tourist accommodations. There's also a lot of boats going in and out of that port out to the reef doing charters and fishing and diving trips. Onshore civil works, some of the challenges before you start, there's ant plants, which were a new thing to me. They're like an orchid. They have a symbiotic relationship with ants. So any trees that had to be cleared that happen to have ant plants, so you had to do a survey first. They had to go up and collect all of the ant plants and relocate them to another safe tree, which unfortunately the ant plants don't grow on the bottom of trees, they grow at the top of trees. So there's a lot of rope access work. They're also very prickly and, you know, not particularly nice to be playing with. So all that had to be done and cleared out. Blind-eyed mangroves, something else I hadn't heard of. There's a mangrove there with something in the bark that if you happen to rub it on your hands and rub your eyes, it makes you go blind for a day or two. So also watch out for that. Something that also arrived a little bit later in the piece we didn't really think of, the pond, because it had been flooded so many times, was full of fish. Some good fish, some barramundi, a lot of bad fish. There was tilapia in there, which is a pest species. And they're all living in a beautiful freshwater environment that we were going to turn saline fairly quickly. So we had to, the contractor had to come up with some nice screens around their water outtake for the tailwater, so that we didn't end up with fish pumped out to the Barron River, causing a major public relations issue. So unfortunately, there was a minor setback for the contractor on the way to starting the job when their dredge overturned just short of Cairns, which was going to be the booster. So some changes to the arrangement of the booster pumps had to be made to accommodate that. And then there were lots of other challenges. Crocodiles in the creeks and the pond. Flying foxes also had to be looked after. A beachstone curlew bird that decided it was going to have nests in inappropriate areas near where we were working that you weren't allowed to go near. It was quite wet season, end of wet season when they started work, so it was quite boggy. Getting across private properties, sugarcane farms, sugarcane rail lines, and the major highway connecting the northern beaches and the Daintree area with Cairns, and that took an incredible amount of traffic each day in and out of Cairns. During it all, the Northern Sands site, not the pond we were working in, but the rest of the site remained a commercial operation. So they had to work in and around that operator as well. That's all from me. Thanks for watching and listening. I think we're going to kick over to Charlie now to talk about the Contractors Experience.
Thanks, Tim. Just bear with us while we get Charlie's presentation lined up. Okay, so I'd just like to introduce Charlie. Charlie's a leading professional in dredging, bypassing, reclamation and rack management with nearly 20 years in the coastal and maritime industry. Charlie joined the Cairns Shipping Development Project as Hull Contracting's project manager. He worked closely with Arian Dredging and he was on site overseeing the day-to-day dredging operations. So he provides a unique insight into the challenges and successes of delivering a major capital dredging project in North Queensland. Please join me in welcoming Charlie.
Hello, everyone. Thank you, Tim, for a very nice introduction for me. So after 10 years, project eventually gets handed over to contractor. So I'm here to talk as project manager from Hull Contracting. So it's very much a picture presentation of how we did the project. So as Tim says, we have soft clay and we have stiff clay. So soft clay was by RN Dredging's Boulder trailer suction dredge, which is really just big vacuum cleaner in the ocean. And then stiff clay by Wimmera, nice digger dredge. And a question for anyone who doesn't work for a dredging company, which Joel will provide a prize at the end, if they can tell the difference between a backhoe and a back actor dredge. Okay, so soft clay we start with, vacuum cleaner. So you got to get it to shore. So it's very nice to suck it up in the ocean, but you have to have three kilometers of ocean pipeline here, which is a long way in the ocean. You have to cross. It's hard to see, but you can, if you zoom in on Google Earth, there's actually, they picked the spot as a river mouth, which is nice, a convenient place to come to shore. But actually means it has a shallow bar that comes across it. So to get decent water access for something like a multi-cat, which needs about 4 meters, when you've got a bit of underkill clearance, you're 1.5 kilometers offshore. So from first kilometer to 1.5 kilometers, there's no access for big size vessels to get in. Then you're coming through land, so heaps of cane fields across the river, and then cross highway into lovely Lake Narelle. And then you got to get water out. So that was 4 kilometers of poly pipe back to the river. Interesting project here. It's such a long way. So you need 2 booster pumps. And what that means is you've really got 3 pumps working. The dredge has 1 pump, then you have another pump, another pump. And if you think you're pumping a slurry mix down that pipeline, that's actually quite a tricky thing to have 3 pumps all talking to each other. So that was interesting. I'll take questions for that afterwards. maybe at the bar. Okay, so what does it look like? So you start with a steel pipe for the ocean. It comes in shipping containers. It's 11.8 meters long. It's not 12 meters long, as a lot of people find out, because when you got 3 kilometers plus 5 kilometers at 11.8, if you count at 12, you're short a few pipes, and it doesn't fit. So they come out, you join them together, and you make for this we made about 100 meters. So that's a welding station just at the beach. 100 meters is pretty easy to drag around with an excavator. And then you join together to make, for this we made about 500 meters. And then when you get to 500 meters, you're starting to push it out into the ocean. You cap the ends of the pipe so it floats, simplistically. And you can see in this one on the right, that's the shallow sandbar that we had to get across. So the way we did that, once we got them all ready to go, you just tow out with a little boat, effectively. So the first bit, amazing what you can tow with a small vessel, but you get out through the river mouth and then you can hand off to a proper sized vessel. Well, they don't tell you when you're rocking up in Cairns to do the job, so you're chasing tight time frame. You're at the end of the rainy season, doesn't want to end, but it's also windy time of year, which is not great because you have pipeline that's floating in the ocean. And where it comes out is not only windy, it wants to blow north, current wants to blow north as well. So this pipeline just, you pull it out, it just wants to like bend around towards the north. So here, these vessels are gently sort of pushing it back around to shore so we could connect together. We did it on this job with a term Japanese ball joint, which was very off-putting to me at the beginning because I didn't understand what it was until I saw it. It's not a ball joint in my mind, but it's fine. It's a rubber connection, so bolted connection to join together, which worked surprisingly well, actually. This is, that's the dredge sitting off. That was a big relief that day, actually, because that was first pumping down the pipeline, which is good. Before we got to there, cane fields, lots of cane fields to get across, lots. And the wet season that doesn't end, and when you're drawing plans on maps, it's very nice. But as you learn, cane fields is pretty muddy and it's not really very trafficable. And you got to get all that pipe out. It's got to come in with trucks, and then you got to take it out with loaders or with excavators or whatever you can track through. And that's hard when it's partially muddy and underwater. And there's more. You can sort of see on the right here, it is a bit, I don't know if mouse work. Sort of one of these thick lines is the pipeline wiggling its way across, lighting around the background. Creek crossing. This one wasn't so daunting really after you've been done 3K across the ocean. I didn't see a crocodile, incidentally. Everyone else saw crocodiles, but I've managed to spend the whole trip without seeing any. But same, you just then cap it and drag it across. These are the two booster pumps. The different designs. The one on the left was Hall, just simple standalone pump and motor sitting behind it. And then here, RN's one, and you've got the pipe going across the creek as well. Then highway crossing, and then they have this really funny little like toy train line, which does all the cane. So when they harvest the cane, they put it in this little, it honestly looks like a little toy train with the little cages. But not only are you chasing time frame to get ready for the dredge, they want to start harvesting as soon as it dries up, so you can't be on the train line when they're running their little trains along. But under highway wasn't so bad. So that was actually, we just towed through. We used one of those super tow trucks, you know, those big recovery things, just with a winch on the back and just slowly snuck it through, no problem. So then you get to Lake Norell. What you don't tell you is actually an active waste receiving facility, I describe it as, that you still have to find your pipeline has to come through somewhere. No, but we find a way through. And then you have to build up these bunds, still in this very muddy kind of wet season. And, there's all kinds of specifications, what you have to meet. You have to reuse existing material. But it's hard, when you can't even track across it. And we have the local contractors there who we use, very good company, HEH, and they said, no problem, we can do, just wait till it stops raining. And we'll come back and we'll do for you, I'm like, no. And they're like, this is how it works at Cairns. When it's raining, we don't work. We just pack up and we don't waste our time. I said, well, this is a different world. This is dredging world. We've got to get this job done. So eventually we did, but not particularly easily. And then pipeline comes in and little pontoon to distribute around. And I have forgotten also that we sprayed in salt water. I would have shown you the very beautiful fountain that we created at the start. for spraying around, which worked good. And then, of course, it's one thing to get your material and your water in, and with the material comes a lot more water than you think or you expect. You know, I forget the exact numbers, but at least 4, maybe 5 times as much water as material, and you've got to get that out. So, and this is a little design we did just to be able to skim the water off the top. That's a suction thing. And then we have a pump and a cage for fishies, and then some silt screens. We had air bubble screens and all kinds of things. And 4 kilometers of this pipeline that goes along to Barron River, which is good. And out it comes and diffuses at the bottom of that as well. And then while this is going on, we're also doing stiff clay, getting ready for Wimmera to turn up. So it's nice, you dig it out, you put it in barges, but then the barges have to go somewhere. And there's another nice picture. And this is where they went to. So right in the kind of the heart of the port. Again, you've got mangroves that have to get nicely cleared out of the way. And it's a shallow kind of water approach location. So we come and we put out a kind of a really small and nimble facility, I would say, rock abutments with a mini pontoon to unload from. I just remember this rock abutment. It just, you kept putting rock in and the rock would settle, and then you put more rock in and the rock would settle. It's probably like double what you can see below there. Yeah. You wonder, you bring it in, you wonder if it's ever going to stop going down, but it did eventually. There it is, looking a bit fancier, should I say. It's quite a quirky facility because it's so small, you have to back down. So small little moxie that backs down to be able to unload, which gave everyone nerves at the start, but once they get the hang of it, no problem, easy peasy. Lovely stiff clay, and then you can see in the background, so stiff clay, beneficial reuse the port uses for surcharging. So that's its first use. It's quite nice, just squashes down the land so you can use in the future. And here we are, more pictures of unloading. Lovely, easy. And then at the end, of course, you know, it's lovely. We do the project, we turn up, but then you have to pack up again. And over that period, the stand kept coming into that river mouth, and the pipeline was never buried when we put it in, and you're getting more and more nervous about taking it out. And people have, there's a lot of kite surfers that find the spot, and you walk down the pipeline, it still looks buried a long way, and you're wondering how it comes back in, but it did. So actually was probably so busy trying to get it out, I never took a proper photo. So this one I noticed while I was doing the slide is actually putting it in, but it's the same kind of principle. You float it up, you pump it full of air. If you're me, the contractor, you're extremely nervous because you now have 3 kilometers of pipeline just floating in the ocean. And those of you who've never been seen pipeline, short length is strong and it's straight, but you make it longer and it becomes like spaghetti. You would not believe it, you know. It's just it bends and it moves. So we were ready with an awful lot of excavators. We had 5 excavators and a dozer, and it's just I would say ground resistance for how far you can pull. And we just pulled as much as we could and got a good 1.5 kilometers in the first day, then sunk, and then the next day we're nearly in, and then the third day done. And then we were then a sigh of relief. That sort of put it into perspective. That's all the pipe stacked up. Yeah, end of the job. And then it looks like we never been there. Beautiful. You know, and I'm sure mangroves are growing back and returning to how it was. Yeah.
Now I invite Tim and Charlie to have a seat, and we can do a bit of Q&A.
Hard question.
This is for the two of you.
Any online? Or should we go to the floor?
Yeah, so for those of you who are watching online, let me just, hopefully you're getting just a video now of Tim and Charlie. So if you do have any questions, just write them into the Q&A. We'll take a few questions from the floor first. So start typing them in to the Q&A, and I can read them out to Tim and Charlie. Just in terms of how the AV is set up here, for the people who are watching online, they won't be able to hear your questions. So if people from the audience want to ask a question, I'll just repeat it for those online, and then we'll hand it over to Tim or Charlie to answer them. So I've actually got a couple of questions for you each before we go to the floor. So firstly, for you, Tim, I'd like to hear from the consultant's perspective, is there any advice that you would give to dredging contractors when completing similar works?
Thank you. You can hear me all right?
Yep.
Yeah, no, if anyone's unlucky enough to get involved in a job like this again, that has a varying and flexible scope and conditions, I think the only answer, the only thing really is that you have to be able to be flexible. You have to be able to chop and change as the project proceeds, because you can't define this job from start to end with exactly how things are going to work out, because there are so many things that could change. Wet season starts, water quality, all sorts of other issues. So from the contractor, and it also then has to be from the project management side, you have to be flexible with each other, and you have to be able to work together in a cooperative manner. If you went in a sort of conflicted manner, I don't think the job would ever have gotten done.
Thanks, Tim. Similar question for you, Charlie. On this project, is there any advice you'd give to dredging consultants when they're planning or managing these kind of jobs?
Bearing in mind you are now a dredging consultant.
And just to maybe Tim can remind me, how many conditions were there? 500 and something else?
Yeah, that was out of our control.
I can say this as I'm consultant now. I think I'm a fan of early contractor involvement. So I think so much of those 10 years is spent in the office designing things and not as much in the field seeing how they'll actually get built. So I think we get tangled up in procurement processes and worried whether or not we can speak to contractors. But I think there's a huge amount of knowledge that sits in contractors' experience that doesn't necessarily make it into those pre-bits of work.
Thanks, Charlie. It's right open to the floor. Does anyone have any questions for Tim or Charlie, or both of them? Claire. I'll just repeat the question for the people online. So the question is about whether there's any sort of research papers that might be coming out of some of the novel work from the project.
Not so much from the saltwater flocculation work. There are a couple of papers coming out for coasts and ports next year, I think it is.
Yep.
Which would have been this year, this would have been after that. So I think there's a couple of papers on that. One on just sort of all the approval issues and challenges. And I think there's another paper on the numerical and experimental design tool that we had, DMCAT, for measuring the siltation, the sedimentation. There's now, I think there's a paper on that looking at how it actually turned out compared to how we thought it might turn out. There's also someone from UQ, whose name escapes me for the minute, also tried to do some assessment of the place material density using a novel technique from UQ. That links back to some of our work too, because it's very hard to measure in situ density of a slurry or a loose material in the ground.
Thanks, Tim. Any other questions? Peter.
that
I'll just repeat the question for those online. So the question is about whether the offshore versus onshore disposal is an efficient use of taxpayers' funding, and whether that's the most cost-effective way to be running these projects.
I think in an ideal world, absolutely. I think that offshore disposal site could have accommodated that material in an environmentally sensitive and safe manner. That's my opinion, my understanding. However, the legislation was introduced and it was simply banned, and there was no opportunity for that. There's no flexibility in that. That capital material in the World Heritage Area from Cairns Port was not allowed. It just couldn't happen, and there was no other sites that were outside of the World Heritage Area that were accessible. So there was opportunity. I think under the rules you could have done a reclamation from shore, but given the proximity of the Cairns CBD and the tourism and the social aspects, that was also not possible. You see Ross itching to.
Ross,
you probably know a bit more about the legislation.
I'll repeat that one. So the question was that the project went from a 5 million cubic metre design volume down to 800,000, and how was that achieved?
Okay, so I can first say it's not me. This was the the Port Authority. I think they just narrowed down their wish list for what they thought they could achieve. So I think back when they started the job, they thought they'd go for whatever they could, and it would have been done offshore. And I think they then spent a lot of time working with the harbour master and the pilots and convincing them that they could bring the ships down narrower channels. They probably also accepted that they'd have some more restrictions on what tides they could bring the vessels in on. So they went from a Rolls-Royce channel to a more realistic channel under the conditions. Yeah.
Claire. The question is, has there been any feedback from, I'm guessing from Ports North and the industry?
To be honest, I don't actually know how many cruise ships have been down the channel, because no sooner had we finished, COVID arrived, and if there have been, they've probably only been small expedition of lower passenger number size vessels, and I don't think there is some video of the QE2 going in there, so they must have got something in there. But it wasn't that much long after we finished and the wharf was done when everything came to a stop.
I can give you an interesting anecdotal on that. So when we first turned up in Cairns, we were worried about telling everyone that we're working on the dredging project, that they might somehow, I don't know, lynch us and chuck us out of town. But then after you're there for a while, you just give in, like people ask you coffee shop, what do you do? Oh, I'm here doing dredging. They're like, oh, really? You're doing the dredging project? And we're like, yeah. And they're like, how deep is it going to be? Right? That would be the first question. And you tell them, and they go, oh, can you make it deeper? Yeah. Can we have more? And what you don't realize is that actually in Cairns, those cruise ships are a massive part of their income and the industry, and everyone loves it. So I don't know for pilots used to the channel, but as soon as the channel was finished, everyone was stoked, like genuinely really happy and pleased that the project got off the ground.
Any other questions? Brad? So the question was about meeting the dry density requirements on the bund construction.
I think they were slightly relaxed from them.
I think probably for the expertise of the contractor. With a lot of difficulties and some flexibility with the council's engineers and a bit of negotiating and a little bit of just having to get it done because the dredge was on its way.
So it wasn't an engineering prescription necessarily. It was a local government operational works requirement for it.
Yeah.
Any other questions from the floor? I'll just check if we've got anything online. Okay, so we've got a similar question from Gramaswara, was asking about how the quantity of dredging was reduced. So I think we've asked and answered that one. And they've asked a follow-up question, whether any scour protection is provided to the offshore pipeline, or is it directly placed?
No, it was directly placed on the seabed inside a 10-metre wide corridor that we were allotted. 10 metres, just to note that. So question for Tim, Why was it a 10-meter corridor, and why was it a 3-kilometer pipeline? And why didn't it go straight out from the shoreline when in an angle? If it had gone straight out, it would have also saved a few hundred meters.
Love it. Great question.
Yeah, I'd have to dig back in the archives, but I don't recall exactly. I think the end point was chosen based on making sure that the connection point could accommodate the range of potential dredges that would have bid on the jobs, because again, you're having to design these things before they've gone out to tender, and you don't know what vessel's going to turn up. It would have been nice to have a corridor for the attachment point that extended further inshore, but the size of that mooring point was an environmental constraint, and having anything too large would have then caused further approval conditions. So it was a balance of getting the conditions, getting an approval to suit. 10 metre wide, I'm not sure. That's probably the same reason. It would have been a potential impact to benthic habitat constraint and trying to minimise that.
It's just an interesting observation. So with the dredge that actually turned up, it could have been a kilometre shorter, but you're constrained by your environmental approval conditions. So when you're talking with a step back, yes, it meets all the conditions, but is it money well spent? That's kind of the question I have, and that's probably my question for us all, as you know, like as this kind of community. How do we challenge ourselves that these projects are actually genuinely giving us net benefit?
Thanks, gents. Any other questions? Lyndon. The question was just about the geotechnical conditions offshore or onshore, Lyndon, or both? Geotechnical conditions in the dredging area and any challenges that were encountered.
Start initially. I don't think the material was any harder to dredge than thought. I think we ended up with less stiff clay than we thought we were going to encounter. So they were probably conservative on the stiff clay side, which meant more was dredged by the trailer, which was probably negative for haul contracting because they were getting paid to dredge the stiff clays. But there were no concerns raised by the contractors about the material difficulty in dredging, but other concerns probably more onshore geotech. I'll go to Charlie.
It's quite interesting. So normal boreholes, etc., but then it got interpreted. So it got interpreted by the geotech engineers as to how much stiff clay and how much soft clay there is. And then that's how you plan it as a dredging contractor. You don't necessarily interpret all the boreholes exactly yourself. You're taking some of it on the balance of what the other experts have told you. So the balance of what was soft and what was stiff was totally different to what was originally predicted. And the reason it was totally different is they were conservative for there being more stiff clay in the way they interpreted. So that's how they did it, speaking to the geotech person who did it. But that kind of conservativeness, or the way those assumptions were made, never made its way through to contractors' reading and understanding. Not say it wasn't in there, maybe it was in one of the appendixes of the reports that were up on the screen. So that was a big surprise when everyone turns up. Is not as stiff. We're like, well, why is it not as stiff? The trailer can suck this up. Why don't we not put it all in the pond? There definitely was some stiff clay. You had to turn up for it, but those proportions, just wasn't clearly understood by the contractor, I would say.
Thanks, gents. Any other questions? Brad. So Brad's the follow-up question is, how does the limitations on the disposal site then influence how the split between stiff and soft clays?
I think the entire responsibility for the disposal site was put on the contractor. Oh.
Would have been contract risk would have been lying with the contractor. The design risk and planning for approvals, whether there was more conservative or less conservative. If I recall, that assessment was done before we really started getting into the final disposal site, because it was quite an old geotech investigation from memory. And to be honest, it didn't have a lot of boreholes. It had a few, but if you did it again, if it was our choice, I would have done a few more probably. But it is what we were given.
Any other final questions? And it looks like we have one more coming through online. Just give this person a minute. No, it looks like it's going to wait. So without any other further questions, we'll end it there. Please join me firstly in thanking Tim and Charlie for their great talks and Q&A session today. And also, if we can thank our two sponsors tonight, BMT and Hall Contracting.